Hello, welcome to the stream. So let's start already. Um, Actually, yesterday I finally completed making SNS, and in my last live stream, I made myself a setup file, and that setup file was not working in my virtual box, but it did work on my brother's PC. Here's the screenshot. Uh, so today morning, as Philakas, I go by two nicknames, Philakas and Theos. Theos is the developer and Philakas is the cybersecurity professional. So before going further today, Theos developer hired Philakas, the ethical hacker, to allow him to test his application. So here is my report of the test so far. Report by Philakas state subject is analysis of TCP stream between host and the listener using Wireshark. So uh, wait, on SMS. Yeah. So basically what I did here is I again established that SNS connection between my virtual machine and my host laptop. And in my laptop, I sent a command of IP configuration to my listener. And I just captured the stream on Wireshark. Uh, one, so 179 to 188, that's like nine packets got exchanged between these. And here I was just, what do you say, analyzing those packets to make sure everything is safe. But I know myself that it is obviously not safe because I did not implement any encryption. So first TCP handshake happened here. I'm not interested it to explain a three-way TCP handshake here. You might just go and Google it if you don't know. This confirms the host has successfully, blah blah, and then finally I could see the data here of IP config, and I could also see the what do you say, response to that IP config. That is the IP address of listener machine. So my conclusion is the analysis has highlights a critical security vulnerability, exposes sensitive data such as commands and system operations. Now, I recommended myself that I must implement encryption in the application to ensure the confidentiality of the data being transferred between host and the listener. Without encryption, obviously the application is unsafe. So right now I was trying to implement PKI in this because I'm going to make decentralized network in future. So I'm starting with something which I can later scale up. Uh, Before going any further, wait a second, let me just make it a subnode. Yeah. So how many tricks, like what kind of encryption can I put in this? First one is PKI. Now, what is PKI? PKI is public key infrastructure. Second one, what else can I implement to? Yeah, basic uh, cryptography, like let's say base 64, base 32, MDA, SHA 512, SHA 256. But all of this, it will just like all of this is easy, like it can be easily decrypted. You just need this CyberChef thing. If you don't know what CyberChef is, let me show you that tool real quick. So you can see um, this can encode and decode anything. Basic encoding. So this is actually not encryption. It is encoding. Encryption and encoding are two different things, right? Or wrong? Yeah, yeah. Encryption and encoding are two different things. So I can input anything here. Let's say here says hi. I'll put it to base 64. Then I'll get this output. This is obviously unreadable to human. So I'll just put it back here and later I'll decode it and it says Theo says hi. So encoding and decoding is really basic. I don't want to put that because if anyone is smart enough to capture it, they will obviously be smart enough to decode it. So yeah, I would rather go with PKI. Now, what is PKI? PKI is public key infrastructure. It is a triangle between a client, a server, and the certificate authority. Um, yeah. So it is a triangle between the client server and the certificate authority. And I mean, yeah. So what happens here is two keys are generated by every client. Uh, so those two keys are first one is public key, second one is private key. The private key stays with the person or the client, let's say here, or the server. And while the public key, it is visible to everyone. And that's whenever I'm trying to connect to someone, let's say person A is trying to connect to person B. Let me use some paint here. I'm not very good at this. I mean, painting. So don't mind my ugly ah s- uh, drawings. Okay. So wait. Yeah. Mm, how do I thicken this? Can I even thicken my pencil? No, I can't. Can I? Never mind. So let's say A and B are two people. They both have their public key and they both also have their private key. B has his own public key. B has his own private key. Now, let's say, and yeah, I'll do A and B here. So this is A's public key and this is B's public key. Both of their public keys and private keys are obviously all different. Now, if B wants to send a message to A, what he will do is he will first fetch the public key of A. After fetching the public key of A, he will infuse it with the message. And after infusing it with the message, that message will be encrypted, which will be readable, which will be non-readable to anyone trying to, what do you say, get in their connection, like trying to tap their connection. Let's say C is the hacker here and C is trying to understand what is going on between A and B. And A and B are having some confidential chat. So B gets the public key of A, he encrypts it, and after encryption, he sends it back to A. And while sending it back to A, even C gets that message, this message. But this message is right now encrypted with the public key of A. And when this message is encrypted with the public key of A, it will be decrypted only and only with the private key of A. So it's like without this private key, that message will be unreadable to C. And that private key, C will never get to know what is the private key there. Same about B. If A wants to communicate anything with him, he will get the public key of B. Let's say C also gets the public key of B, but he will still be unable to decrypt later what A has told in that message. Now, what I explained here was AES or asymmetric encryption, something I forgot the full form. My bad. Yeah, advanced encryption standard. Uh, this one is an example of advanced encryption standard, which is asymmetric. Public and private keys are generated in asymmetric as well as symmetric, but In PKI, we use asymmetric. So this one is, it is obviously it is a long process because first A will request something to B, and then B will fetch B will fetch the public key from A. After fetching that public key, B will encrypt that message, and after that he will send it to A. And after A receives it, he will decrypt it with his private key, and then he will be able to read the message. That obviously takes a lot of time, but this is the most safest way. There are also symmetric keys in encryption. Symmetric key, obviously, from symmetric, you might understand that symmetric key, if I get to know someone's public key and the encrypted message, I can decrypt it. In symmetric key, there is a chance, but in asymmetric key, there is no chance that you can decrypt any message without the private key. Symmetric key, it is actually faster than asymmetric standards, but yeah, right now I'll be using asymmetric only because it is safe, and I'll be implementing this in my project. Now, another question arises is when A gets the public key from B, C might put his own public key with A. Like instead of what will happen here is this has become a mess. Let me clear this. Yeah, okay. Now A and B again here. Now, and let me put C here. No, C is not that small. C is also big. She is also big. Well, never mind. So when B is sending his public key to A, at that time, the connection might be interpreted and C is a hacker, okay? Yeah, C is a bad hacker. Unlike me, I'm a good hacker. So C is a bad hacker. What he will do is he will put his own public key instead of B. So he will make sure that their connection won't be succeeded. And when A gets this public key, wait a second. Now, just to explain it in a better way, yeah. Imagine there is a pipeline between A and B. Here, B is sending his public key through that pipeline. What C will do is, C will put a hole in this pipeline. He will remove that B's public key and he will insert his own public key in this pipeline. After that, he will send it to A. After A receives it, uh, like after A receives it, how can he make sure that this public key belongs to B only? How can he make sure that it does not belong to C? Here comes another part, that is certificate authority. So, certificate authority is what is it? It is a third party authority which which ensures that the public key which you are getting from someone belongs to them and only them. Uh, so yeah, I need to set up my own certificate authority if I want to implement PKI into my own SNS. Now, getting back here, um, yeah. Uh, PKI relies on the cryptographic keys, a public and a private key. Data encrypted with public key can only be decrypted with the private key and vice versa. A digital certificate binds yeah, when I say that B is sending his public key, right, at that time he's actually sending his digital certificate. I forgot to mention this. So B is sending his own digital certificate. Digital certificate is nothing but a certificate that has the name B. Like it certifies that this is the public key and this actually belongs to B. So that's the digital certificate, and C can interpret this and put his own digital certificate. So after receiving the digital certificate, A will ask to certificate authority if this certificate belongs to B or C. If this certificate authority says that it belongs to C, the connection there is revoked, and if it actually belongs to B, then connection is successfully made here. So CA is the CA is a trusted entity that issues and manages the digital certificate. It verifies identities and ensures that the public keys. Let's say B is going into an exam. A is the, what do you say, examiner. And while B is going, he is kidnapped in midway, and C takes B's ID card. No, sorry, my bad. B is going to the exam, and C makes B to wear his आईडी कार्ड. सो अभी बी ने सी का आईडी कार्ड पहन के अगर बी ए के पास जाता है, तो ए जो है क्लास टीचर के पास में जाके पूछता है कि ये आईडी कार्ड, मतलब ये बंदा कौन है, ये बंदा क्लास का है या नहीं. तो सी ए जो है आईडी कार्ड और वो आईडी कार्ड एंड दैट पर्सन, द आईडी कार्ड हियर इज व्हाट इज डिजिटल सर्टिफिकेट or the identity, and the person is the public key. So, class teacher makes sure that this card belongs to this guy only. And if class teacher approves, examiner lets the student sit in the class, or it tells him to get out. That's it. CRL certificate revocation list, that is not really necessary. This is a list of certificates that have been revoked by CA before their expiration date. अभी एसएनएस में पीकेआई का इम्प्लीमेंटेशन क्यों चाहिए? यूजर ऑथेंटिकेशन होगा, सिक्योर कम्युनिकेशन एस्टेब्लिश होगा, डेटा इंटीग्रेटेड रहेगा. और अभी ये कैसे करना, ये मुझे समझ नहीं आ रहा. मैंने बहुत कोशिश की बैठने की. अभी के लिए तो व्हाट आई अंडरस्टूड एज ऑफ नाउ इज ये सब चीजें, ऑल द theoretical part, and OpenSSL is another open source software. I could have used Windows Server's Active Directory server certificates, but I did not use it because I want to make it platform independent in future. So if I use this, it will be only like applicable to Windows devices, obviously. That's why I am using OpenSSL. As of now, I have installed it. तो ओपन एसएसएल के अंदर ये पब्लिक की प्राइवेट की बनता है, और अभी बनने के बाद में, उसके बाद में सीए बनाना है और बाद में इम्प्लीमेंट करना है. दैट इज समथिंग दैट आई कांट गेट थ्रू. सो डोंट सेव, ऑब्वियसली डोंट सेव दैट अगेन. यस. इज एनीवन वाचिंग माय स्ट्रीम though? Yeah, just a second. Mm, or I'm just yapping all alone by myself. Probably I'm alone. Ah, okay. Anyways. Now, let's learn how to use OpenSSL. Let me search if they have obviously they might. OpenSSL Windows tutorial. Install master. Why is he explaining this with chocolatey? हाँ, okay. I don't know. Let's see. क्या कर रहा है ये? The tutorial will be configuring OpenSSL, invoke a web request and all. हाँ, बहुत सारी चीजें दिमाग के ऊपर से जा रही है अभी के लिए तो. But yeah, and I really need someone who can explain me how to use OpenSSL in this. Generating SSL certificate can be a daunting task. It sure is a daunting task even before I started learning it. One filled with frustration and sorrow. Why do I why do I relate so much? But it doesn't have to be that way if you have Windows 10 and OpenSSL along with a little help. Not a reader. I am a reader. In this article, you are going to learn how to install OpenSSL on Win 10. Once installed, then you will be able to generate SSL certificates, troubleshoot and debug certificates, and convert between formats. Damn. Okay. Prerequisite. In this article, you are going to learn Windows with local admin rights, Windows PowerShell. Yeah, I do have a PowerShell. I don't have this chocolatey. What is this chocolatey? Let me sir. Let me check first. Package manager. Okay. Uh, is it actually safe? Hmm. Okay. Seems pretty widely used. Okay. I mean, I usually do this for my own surety that I'm not installing any uh what do you say lowly used application. Subscribe optional. Choose your installation methods. Choose how do you want to install. Man, questions. Install with Power PLC. Check the supported Windows client. Partial will do. Know the requirements. Huh? S- okay. Yes, I'll go for individual use. First, ensure that you are using an administrative shell and you can also install with partial. You initial this is pass this to get quite a bit more security to me. Okay. Man, what copy paste नहीं है usually होता है don't look don't judge me so, get execution policy remote signed if I copied this I can paste it inside एक सेकंड में पार्शल की जगह ब्रो कंट्रोल शिफ्ट में से कॉपी पेस्ट होता है इसमें नो पार्शल में ही होता है फिर क्या इंस्टॉल हो रहा है? हो तो गया अभी चौको. Okay. The name is pretty weird. Choco. Yeah. PowerShell ISC or Visual Studio Code. Any text editor. Okay. Installing OpenSSL in Windows 10 with PowerShell and Chocolatey. OpenSSL तो already installed है. Bro, why am I so stupid? I just am. Anyways, just a second. Let me check my messages. So, my bad. So, setting up a working directory, this tutorial will be creating a few certificates to learn from to ensure all of the work you do here is combined to a single confined soldier folder. You can clean up, go ahead and create one. Okay. The this tutorial will store all. Okay, no problem. हाँ, बन गया certs. Now configuring OpenSSL. By default, Windows 10 does not come with a configuration file. This is intentional because there are specific configuration of the parcel and run the command. The okay, you can now open this something like this below. कहाँ बनेगा लिखे नहीं है. Let me go to search. हाँ. हाँ, अभी क्या है, इसे ओपन कर लो. टिपिकल लिनक्स यूजर प्रो. हाँ. सो ओपन करने पर क्या दिखेगा? This is OpenSSL configuration file. This is mostly on readme. हाँ वही है, same है file. The downloaded configuration will work as a as it is for now. Do not use defaults in the production environment. Okay. है क्या, लेकिन खोल के पढ़ना चाहिए मुझे. Certs open with Visual Studio Code on this. Okay. This is the OpenSSL example configuration file. This is mostly being used for generation of certificate requests. This definition stops the following lines. Okay. Isn't, no, okay. Here's configuration file with this. I'm just trying to read all the details and understand as much as I can. Alternatively, use a configuration file that has only this. We can add OIDs here. Okay, directory is demo CA. ठीक है. Certs is equals to directory certs. यहाँ सर्टिफिकेट रहेंगे CRL underscore dir. This is where the issued certificates are kept. Database index.txt. Okay. न्यू सर्ट्स में नए सर्टिफिकेट रहेंगे। सी ए, ये कहाँ? सी ए सर्ट डॉट पी ई एम। ओके। सी ए मीनिंग अगेन सर्टिफिकेट अथॉरिटी, तो सर्टिफिकेट अथॉरिटी का सर्टिफिकेट 41 फाइल में मास्टर डेटा। उसके बाद में सीरियल सी आर एल प्राइवेट की वन फाइल। हाँ। ओके, सो कॉन्फ़िगरेशन फाइल में नेक्स्ट टाइम यूज़ करने के पहले, एसएनएस में यूज़ करने के पहले मुझे एक बार पूरी तरह से फिर से सेटअप करना पड़ेगा। अभी के लिए लेट अस कीप इट एज इट इज एंड कंटिन्यू विद आवर ट्यूटोरियल। Update the PowerShell profile environment variables. You should modify PowerShell profile on Windows 2. Setting up, setting up what environment variable allows you to. I suggest starting to environment path. The path variable below is using. Okay. इसमें क्या कर रहा है? एनवायरनमेंट पाथ डाल रहा है। ओपन एसएसएल का तो ऑलरेडी है। ओपन एसएसएल पिन का ऑलरेडी है, लेकिन ये नहीं है। environment identify behind these lines. दूसरा कहाँ? सी सर्ट्स ओपन एसएसएल। मैं जीयूआई में करूँगा सेम चीज। एनवायरनमेंट वेरिएबल्स बाद में जाके क्या? सी सर्ट्स ओपन एसएसएल डॉट सी एन एफ पाथ एडिट न्यू ब्राउज दिस पीसी सी सर्ट्स। एक सेकेंड। सी एन एफ, वेट व्हाट? दिस इज वियर्ड। ओके, whatever. ये बात में डालना as far as I know बस फोल्डर डाल फाइल। but okay I guess. ओके, ये हो गया। ओ नो, बंद नहीं करना चाहिए था वो। सी सब सब। अभी क्या ओपन एसएसएल वर्जन? हाँ, मेरा वर्जन लेटेस्ट मैंने डाल के रखा है। नाउ यूजिंग ओपन एसएसएल टू जनरेट a CSR and a private key. Okay, before you can create an SSL certificate. एक सेकंड, कल मेरा हैकाथॉन है एक्चुअली। आई एम नॉट डूइंग दैट। ओह, 3 तारीख से मतलब कल से शुरू हुआ। 9:30 प्रोडक्शन। डन। जस्ट अ सेकंड बस। अगर ये लाइव स्ट्रीम बाद में देख रहे हो तो 20 सेकंड आगे स्किप कर लेंगे। तो फिर है। No problem. I'm doing it for myself anyways. I don't expect anyone to post this because I know that मैं मुझे खुद को ये देखने को बोर होगा. Using OpenSSL to this and this and this and this. Okay. Before you can create an SSL, you must generate a certificate signing request with a CSR. CSR is an encoded file that provides you a way with the public and that contains signature algorithm. Let's create your first CSR and a private key. Okay. Run the command below. Um, then o- OpenSSL will then prompt you to enter some identifying information. I see. Can okay. क्या कर रहा है ये? OpenSSL request. Stupid notifications. Stupid. OpenSSL request new out my first user. Okay. Select new organization. um, Okay. Huh? What just happened? Wait. Okay. Enter PM passphrase. So इसमें मुझे क्या डालना है PM passphrase में? Anything? It is a passphrase after all, right? अभी के लिए I'll keep some simple passphrase, I guess. New out my first CSR. Wait, let me cancel this. I can't. I can. Uh, okay, I have to delete that private key.pem. अरे रह गया था ना पहले. Passphrase में कुछ गया नहीं था. Enter the PM passphrase. Okay, I'll just put 1234. 1234. Yeah, country name India. Oh, two-letter code. IN. State province name Gujarat. Locality name. I don't wanna give out my location. Just a second. हाँ हेलो. नहीं मैं अभी स्ट्रीम कराने बाद नहीं करता. हाँ. Okay, so locality name, I don't wanna give out my locality name. I'll just put in some random thing like Dystopia, Utopia, not dystopia, Utopia. Organization name, um, yeah, SNS Private Limited. Organizational unit name, developers. Common name, my name, yours. Email address. Um, oh, okay, a challenge password again. An optional company name. Optional company name. What? Okay, that's it. ये वाला तो हो गया. Now I'll do LS, my first CSR, I will cat. Okay, looks good. I will cat private key. Okay. Once you have a valid CSR, uh, 1 second. Okay, I have a certificate signing request here, CSR. So once you have a valid CSR and a private key which can be used in an SSL certificate to you, the configuration file defaults can be edited further to streamline this process. Should you not want to enter the data every time you want to generate a CSR? I don't know. Generating RSA key pairs. So public और private key बनेंगे. So सबसे पहले create a private key using gen RSA. Generate RSA as shown below. Okay. Next, generate a public key using the following command. The syntax below will create a public key called RSA public directly from the RSA private key. Okay, राइटिंग RSA की हो गया. तो अभी मेरा पब्लिक और प्राइवेट की बन गया है. हाँ. Now generating a self-signed certificate. On occasion, you might want to generate a self-signed certificate. These are fine for lab use, but not a secure practice in a production environment. Okay, as of now, at least for learning or implementing, should I use it? I'll think it later. Anyways, बहुत आगे का सोचने की जरूरत नहीं. So let's create a self-signed certificate before moving next. Command below to create an X509 SSL certificate. The certificate will use SHA 256 cryptography that will be valid for 365 days using an RSA of this. The certificate will be saved to the working directory. Let's see. Let's try to break the code. 1 second. To see. 1 second. ls RSA public RSA private dot pem ओपन एसएसएल cnf प्राइवेट की. हाँ, ये गलती से बन गई. लेट मी डिलीट दैट. ओके, प्राइवेट की को मैंने उड़ा दिया. और मुझे ये ओपन एसएसएल रिक्वेस्ट x509 SHA 256 notes days 356 365. I can increase the number of days, right? Okay, I will do it later. RSA 2048 ये हमने पहले मेंशन किया था कि 2048 साइज का बनाना है. Key out private key out. Okay. Now again, country name IN Gujarat, Utopia. Organizational parliament name. ए, इतना सब कुछ क्यों पूछ रहा हूँ? It's weird. Okay, प्राइवेट की बन गई फाइनली. You are now ready to import a certificate into your server or your browser. Now, how do I validate it? Checking the information in CSR, private key certificate or PCKS hashtag to let me see here. Can save you time troubleshooting SSL errors. Sometimes a wrong key may be used to your certificate. For example, you may have wrong identifying information in the certificate. Let's start by checking REQ. Oh, she. It should match precisely. I guess I just randomly put in something. दोनों के अंदर सेम डाला था क्या ना? नहीं ना? Don't tell me I have to do everything again. Let's hope this works. Okay. क्या पास या नहीं? Oh, text no out verify in. Okay, let me read this. You can also check certificate using this modulus. अलग अलग बन रहा है ना मेरा? Okay, this tutorial is kind of confusing. No, Utopia SNS Private Limited. Okay, मैंने ये सब कुछ तो सेम डाला था. Validity not before this and not after this. Okay, एक साल का 365 days का था validity वहाँ. और इस encryption modulo and more. अगर मैं मोर को एंटर दबाते तो बना के जाएगा नहीं. ओके CA सर्टिफिकेट अथॉरिटी ने ट्रू बोला. Yeah, that's it. Ah, okay, so it does matter. Converting certificates with OpenSSL. There are occasions where an application does not use a particular certificate format. You can run into माइक बंद था मेरा। कितनी देर से बंद था? जस्ट यार, आई गेस। ओके, इतना ज्यादा टाइम नहीं हुआ। ओके ओके, एंडिंग एंडिंग में माइक बंद हो गया था। Anyways, if you are watching until here, thank you so much for watching this. And yeah, obviously you can text me on Instagram always. I have something for you if you have watched it until here.